Let's play a game. Point to the nearest star. Did you point to the sun? Good. Now point to the next nearest star, the one after our sun. Go ahead, I'll wait. You probably just gestured vaguely at the night sky, at any one of those tiny twinkling lights. But here's the terrifying, beautiful, and humbling truth. The distance to that next star isn't just a bigger number. It is a void so profound, so empty, that if you truly comprehend it, it will warp your sense of reality. It is a distance that makes our entire solar system look like a single, lonely dust mote floating in a silent, endless cathedral. We are about to measure that distance, not just in miles or kilometers, but in shattered human assumptions, in frozen time, and in the desperate loneliness of our spaceship Earth. This is not just astronomy. This is a mirror held up to our place in the cosmos, and what you see staring back will change you. First, let's get our bearings right here, in our own celestial backyard. The sun, our personal star. Its light traveling at the universal speed limit, 186,000 miles per second, takes about 8 minutes and 20 seconds to reach us. That's 93 million miles, or 1 astronomical unit. It's a distance we can almost wrap our heads around. Our fastest spacecraft, the Parker Solar Probe, screaming through space, could theoretically make that trip in a couple of months. From the sun, we go outward, past the rocky planets. It takes light from the sun about 4 hours to reach Neptune, the icy sentinel at the edge of our planetary family. This entire kingdom of the sun, all the planets, asteroids, and comets held in its gravitational embrace, fits within a bubble roughly 1 light day across. It feels big. To us, it is incomprehensibly big. But in the story we're telling today, this entire majestic solar system is just the title page, the prologue, the first single step onto a beach before we stare out at the ocean. Now we take that second step. We leave the sun. We push past the Kuiper Belt, past Pluto's dance, past the sleepy comets in the Oort cloud. We are now in interstellar space, the domain between stars. And here, the rules change. The scale shatters. Because waiting for us there, just 4.37 light-years away, is a pair of stars. A binary system called Alpha Centauri. More specifically, there's a faint reddish star named Proxima Centauri, which currently holds the title of our sun's nearest stellar neighbor, 4.37 light-years. Say it out loud. It sounds neat. Manageable, a small number. It is a lie. A light-year is not a measure of time. It is a measure of distance. The distance light, the fastest thing in existence, travels in 1 entire year. That's about 5.88 trillion miles. Multiply that by 4.37. We are now talking about 25.7 trillion miles. Let's try to murder this number. Let's make it bleed meaning. Imagine you could shrink the entire solar system, from the sun to the edge of its influence, down to the size of a single coffee cup. A nice, warm mug holding all our worlds, our history, our everything. On this scale, where would the nearest star, Proxima Centauri, be? Take that coffee cup, place it on your kitchen table. Now, get in your car, drive for 45 minutes, get out, walk into a football stadium in a city nearly 50 miles away, go to the 50-yard line, place a second identical coffee cup there. That is the distance between our solar system and the next cup of stars. The space between them is nothing. A near-perfect vacuum, colder than anything we can create on Earth, dotted with maybe a few atoms of hydrogen per cubic centimeter. It is an emptiness so complete, it makes the void between planets look as crowded as a rush-hour subway. This is the neighborhood. This is the insane, sparse distribution of matter in our galactic suburb. Stars are not points of light crowded together in a pretty tapestry. They are unimaginably lonely beacons, separated by deserts of nothing so vast they defy human intuition. Now, let's make this personal. Let's send a human. Forget the speed of light for a moment. Let's use our best, our fastest, our most insane piece of human engineering. NASA's Voyager 1 probe. It left Earth in 1977. It is screaming into the void at about 38,000 miles per hour. It is the farthest human-made object from Earth. After nearly 50 years of travel, it has just barely stepped into interstellar space. How long would it take Voyager 1 to reach Proxima Centauri? Ready? About 73,000 years. 73,000 years. Let that colonize your mind for a second. If a crew of our ancient ancestors had set out for Proxima Centauri in a Voyager-like ship during the last ice age, when humans were painting mammoths on cave walls in Lascaux, they would not even be halfway there today. The entire span of recorded human history, from the pyramids to the internet, is less than a blink, less than a single heartbeat on this journey. This is the time scale of geology, of continental drift, not of human endeavor. So our fastest bullet is useless, our pride in our technology is humbled to dust. To reach the nearest star in any human meaningful time frame, we would need to travel at a significant fraction of the speed of light. And the moment we start talking about that, we stop being engineers and start being science fiction writers, grappling with relativistic time dilation, with monstrous energy requirements, and with cosmic hazards like specks of dust hitting the ship like nuclear bombs. But light makes the trip in just 4.37 years. That's not so bad, right? Let's ride a beam of light. Even here, the cosmos plays a cruel trick. That 4.37 years is for us, watching from Earth. For the photon of light itself, for the information making the trip, time does not exist. According to relativity, from the photon's perspective, the trip is instantaneous. It is emitted and absorbed in the same moment, regardless of the 25 trillion miles in between. The universe, for the fastest thing in it, has zero length. But for us, the stationary observers, we wait. We wait years for a single bit of news. We point our telescopes and see Proxima Centauri not as it is, but as it was over 4 years ago. We are forever looking into the past. This creates a profound isolation. If we saw Proxima Centauri explode today in a supernova, a fantastic impossibility for its type of star, but bear with me, that catastrophe would have actually happened over 4 years ago. We live in a universe of delayed signals, where our nearest neighbor's hello takes years to arrive. It is the ultimate cosmic lag. Remember our game from the beginning, pointing to the nearest star? You now understand you were pointing into an abyss. That tiny pinprick of light in the constellation Centaurus is not just a point of light. It is a destination perched on the other side of a canyon so wide, we have no bridges that can cross it. This distance is not an obstacle. It is a statement. It is the universe declaring the fundamental solitude of stellar systems. It screams that life, if it exists on a planet around Proxima Centauri, is in a prison of isolation almost identical to our own. They look up and see our sun as a faint star in their sky, just as unknowable to them as theirs is to us. The void between stars is the ultimate ocean, and every star system is an island. We have not yet learned to build canoes that can cross it. But are we doomed to isolation forever? The human mind rebels against this. We are the species that looks at a canyon and dreams of bridges. So we dream of breakthroughs, not of faster rockets, but of paradigm-shattering ideas. We dream of light sails, pushed by powerful lasers, that could accelerate tiny probes to 20% the speed of light, reaching Alpha Centauri in a human lifetime. Projects like Breakthrough Starshot are serious scientific endeavors working on this. We theorize about warp drives, about bending space-time itself, though the energy required is currently the energy of entire stars. We wonder if we could use wormholes, cosmic shortcuts, though they may be mathematical fantasies. The pursuit is not just about getting there. It is about refusing to accept the verdict of the void. It is the most profound expression of our curiosity. The distance tells us we are alone. Our spirit tells us we cannot accept that. So, let's return home. Let's turn our ship around and look back at the pale blue dot. Seeing that impossible gulf to the next star does something strange. It doesn't just make the stars feel farther away. It makes our own world feel infinitely more precious, more connected, more fragile. All of human strife, all of our borders, all of our conflicts exist on a particle less than a speck, adrift in a cosmic ocean where the nearest islands are lifetimes upon lifetimes away. That distance is a cold teacher, but its lesson is one of unity. It screams that here, on this one tiny world, is all we have, all we know, all we can surely depend on for millennia to come. The nearest star is a yardstick, and by measuring the terrifying distance to it, we have accidentally taken the true measure of ourselves. We are small, we are isolated, we are adrift. But we are also the part of the universe that can understand that isolation. We are the cosmos looking out at itself and feeling the ache of the distance. And in that understanding, in that yearning to cross the uncrossable, we find a purpose as vast as the void itself. We are the ones who dream of building a bridge across that 50-mile stadium from one coffee cup to another. Not because it is easy, but because the emptiness between them is the greatest invitation ever written. The distance is not a wall. It is a dare. And one day, somehow, we will answer it.